All right. So Sujay is from the Tesla Autopilot team. They help have cars drive themselves and robots do robot stuff. And today he's going to talk about PyTorch versus JAX. It's a really hard decision to make when you're building or running your own models. And he's going to kind of walk you through the pros and cons of these. So, Sujay.
Hi, good afternoon. So this talk will be a little bit more technical. So I'll be talking about the different deep learning frameworks that we have right now, like the PyTorch and JAX, and the trade-offs that we would do to choose one or the other. So, like we heard from the speakers today, so there are basically two pillars for AI, right? So one is data, and we heard a lot about like the importance of data and like how it would help your AI models. And the other pillar is the models themselves, right? So the model architecture and how we build them and how we train them. And just like in software engineering, AI model architectures and model training itself are mainly dependent on the frameworks themselves and the support that the frameworks give us. So there are like multiple frameworks that that are there in the industry right now, right? And there are some requirements that we have from these frameworks that we want these frameworks to support for us in order to even train any of these models. So there are multiple frameworks. There are like TensorFlow, PyTorch, JAX, Paddle, MATLAB. If people have been doing AI in like 2008, 2010, like MATLAB was like the thing, right? So, but now we have like other frameworks as well. And some of the main requirements that we have from these frameworks is we want these frameworks to give us these high-level APIs for model construction, training procedures like data processing, as well as exporting the model to production, right? So we don't want to be in the business of coding up like matrix multiplication by ourselves, but we want the frameworks to give us like easy interfaces for us to implement them, right? So we also want these frameworks to give us like optimized multi-dimensional matrix operations. So like the speaker mentioned, like the previous speaker mentioned, like AI is inherently in multi-dimensional latent space. So every single vector or the weight matrices that the AI models have are in like multiple hundreds of dimensions. And we want an optimized way of like operating on these matrices. So we also want automatic differentiation, right? So all of us might have taken calculus in our high school or in college, and we know how hard like differentiating functions is, and we don't want to do that for a model with billions of parameters, right? So that would itself take like 100 years. So we want some framework that would do this differentiation automatically for us, and that's one of like the basic requirements that we want the frameworks to have. And hardware acceleration, right? So hardware acceleration has become very important given the scale of the models that we are training at this point in time. So I think one of the main reasons for AI and LLMs to create a storm is basically NVIDIA GPUs, which has enabled us to train a model in weeks, whereas earlier it would take like hundreds of years, right? And it would be intractable. So we need these frameworks to help us efficiently train our models on different hardwares like GPUs or TPUs. And of course, we want these frameworks to support our favorite languages. So we don't want to learn a new language just to train our like favorite models, right? So we want the framework to come to us where we are comfortable in the language that we are comfortable coding in. And so we have like multiple options, right? So we have like TensorFlow, which came up, I think, in around 2013 or 2014, and we have like PyTorch, JAX, Cafe, which I think is still being used in Meta. We also have like Paddle and MATLAB, and right now I think the fight is between PyTorch and JAX. So it's very important for us to find out like which framework would work for us. So usually as software engineers, if we choose a framework and then we figure out that it's not the right fit for us, it's usually too late for us to switch, and we would need to end up doing some hacks around it, just trying to get it to work for our use cases. So in this talk, it's mostly I'll mostly be covering like the main differences between like the PyTorch and JAX frameworks, so that when you go and try to build your own model or try to train your own models and tweak the models that are there in open source, you know what you're getting into, right? So right now, in most of the frameworks that we see, like Transformer Engine from NVIDIA or the models in Hugging Face, you have the option of like choosing both like PyTorch and JAX. And I think these differences would be helpful for you in case you want to make any tweaks to it, or you want to train it further, fine tune it, right? Or even train these models from scratch. So how do we decide like what's the right framework for us, right? So we want the right level of abstraction that is provided for us. So we want the frameworks to give us the extendability of having a high level abstraction where you can just say, hey, I have this model and I just want to train it. I don't care about the internals, right? So we want that level of abstraction, but then there will come a point where you want to make some changes to it, right? So at that point, you want the framework to give you the flexibility to make changes in the code, in how the model trains. So we also want to keep an eye on like the performance and efficiency. These GPUs are thousands of dollars, and you don't want them to be idle. And usually usage is around like 20%, and you're just burning money at that point. So we also want to do distributed training, right? So these large models are large for a reason, and we cannot train them on a single GPU. So we need at least 100 of GPUs to train these large language models, even for like fine tuning. So we want these frameworks to support that as well, right? So the other important thing is like rapid prototyping and experimentation. We want to be able to experiment with these models and not just take something off the shelf and use it as it is. And of course, community and developer support. So I don't think AI would be where it is today without the community support and the open source support that it has right now. So we want some framework that supports and fosters this kind of like open source support, and we have like a huge community of like developers who would like support training these frameworks. So a little bit about like overview on like the ecosystem behind like PyTorch and JAX. So PyTorch is mainly by Meta, and it's an open source training framework that Meta has open sourced, and we can make any changes that we want, like without a commercial license. And PyTorch focuses on dynamic computational graphs. So that means every iteration, the computational graph that gets created is dynamic. So it's not like C++, where we compile the program and then execute the static object later, but it's like Python, right? So where it's like interpreted and every line gets executed one after the other, and PyTorch endorses that, right? So PyTorch is mainly focused on ease of use and rapid prototyping. So I am sure most of you are familiar with the advantages of Python and how easy it is to get started programming in Python, and how intuitive it is, to even understand like a Python program, right? And PyTorch follows the same philosophy of, giving the highest flexibility to the programmers to make any changes, and it's like very easy to like debug a PyTorch program. So it constructs the autograd graph during runtime. So autograd is basically the automatic differentiation part of PyTorch, which does the gradient computation for you on the fly. So JAX is the open source training framework by Google. So it originated in Google Brain during their AlphaGo times, and now it's a part of Google DeepMind. So the main focus of JAX is on the functional programming style. So if you guys are aware about the differences in programming styles of Python and a functional programming like Haskell. So in a functional programming, it's basically about like pure functions and no side effects, and no state changes, unlike Python or object-oriented programming. JAX is focused on high performance computing. So JAX is built from the ground up to have very, very high efficiency on GPUs and TPUs. And the way it accomplishes this is using OpenXLA compiler. So OpenXLA is also an open source compiler that compiles your JAX program into a static graph that gets executed on the GPUs or TPUs, right? So it uses something called JIT compilation, which is like just-in-time compilation, which compiles the graph as you run the program. So coming to the abstraction, right? So how does PyTorch and JAX compare when the abstraction at the different levels of abstraction? So at the highest level of abstraction, we want an easy way of like defining the neural networks, right? So at that point, both PyTorch and JAX provides a similar interface for us to like define the models. So for example, here in PyTorch, we have a bunch of convolutions and ReLU, which we can just write as a simple Python program. It applies like ReLU over a bunch of cons. And similarly, in JAX, you can define the same thing using __ call function, where we can do a bunch of reshapes, and there are like a bunch of linear modules, and creating an empty array, and we can even do initialization, just like how we do in like PyTorch. So it's pretty similar, I would say, the level of abstraction that we get from both JAX and PyTorch. So now, if we want to go even further, right? So we want to go lower in the stack, and we want to do some NumPy operations, right? So both PyTorch and JAX are native NumPy. So NumPy is basically the n-dimensional array operations on CPU, and PyTorch and JAX execute them on GPUs, right? So both PyTorch and JAX are 100% API compatible with NumPy. So if you're compatible with NumPy, you can use either PyTorch or JAX. So in this way, also PyTorch and JAX are kind of similar. So custom CUDA, right? So if you want to go even further, right? So you wanna get the best out of the GPUs that you've bought. So you wanna write custom CUDA kernels that you wanna execute on the GPUs. Both PyTorch and JAX support them. So one main difference here is that PyTorch also supports Triton kernels. So Triton is by OpenAI. So OpenAI has a programming language called Triton, from which you can like run your GPU kernels, and you can easily design your own custom GPU kernels instead of going down to the level of CUDA. It gives a nice trade-off between writing your own kernels in C++ versus relying on what the default implementation is. Most of the good kernels, or the most performant kernels right now, like Flash Attention, are all like written in Triton, right? So PyTorch supports it natively, but JAX doesn't. So JAX has a layer called like Palace over it, which it uses as like a bridge between the CUDA kernels and GPU. So if you have a requirement like this, then I think like PyTorch would be a good option to go to if you want to write your like custom CUDA kernels, right? Yeah. So the TLDR, PyTorch and JAX supports abstractions at all levels. All right, and there are like multiple open source libraries for PyTorch, like Transformer Engine and PyTorch Lightning. If you want a very high level, abstraction where you just want to train a model or fine tune a model without worrying about the internals of it. But if you do want to worry about the internals, then there is always Triton. But in case of JAX, you need to use other open source libraries like Flax or Haiku and Optax. So these are the high-level libraries that give you the abstraction of neural networks, right? So because JAX, at the end of the day, is still a NumPy-compatible program and not a neural network program. Performance and efficiency. So PyTorch was not built with performance in mind. So PyTorch was built with focus on rapid prototyping, right? So it focuses on like the dynamic computational graphs and dynamic CUDA kernel benchmarking. So these are the main things that it does to get really good performance on GPUs. So the flexibility that PyTorch offers is you can change the graph during iteration, right? So as we know, we train the models for like hundreds of thousands of iterations, and in each iteration, a new graph would be generated for us. So this is obviously inefficient. So, but they do have a solution for the change in graph structure every iteration. So they have something called as a torch compile, where you can compile the graph, and it comes with some baked-in efficiency gains, right? Like fusing ops, CUDA graph, and it also generates automatic Triton for you. Whereas when it comes to JAX, JAX is built with efficiency in mind, right? So if you want to have high efficiency and high throughput of training, then JAX is a no-brainer. So changing graphs during execution triggers recompilation in terms of JAX, so that reduces the flexibility that the programmers can have while designing their models. And it also has some of the features of torch compile, like fusing ops and CUDA graphing. And it has lower CPU overhead because the entire computational graph is compiled at once, and then it's executed for hundreds of thousands of iterations. So the TLDR is, if you're using an open source training framework, right? So if you're maybe using Megatron LM from NVIDIA or Transformer Engine, right? Or even Llama 3. So most of these are built in PyTorch. So if you're just using them out of the box, then most of these training efficiencies are already baked into them. So might as well go with PyTorch, right? But then if you want to build your own training, or if you want to tweak some of them, then you have to make sure that you keep efficiency also in mind. Whereas that is not the case with JAX, because JAX gives pretty good out-of-the-box performance. So you just define your program, and the compiler just takes care of making it efficient for you. But then if you want to make some tweaks more than that, then you'll have to learn OpenXLA. So distributed training. So we know that the models that we train are pretty big, and most of these models, we need multiple GPUs to train them, because we just can't train them on a single GPU. So there are multiple levels, right? So if we have a smaller model that fits into a single GPU, for example, the H100 right now is of 80 gigs, and if your model fits into that, then you can train on a single GPU, and PyTorch provides a distributed data parallel for you to train. But but for JAX, you have to use something called as a device mesh, where you can just specify how you want the model to shard and how the device is sharded across everything, and it just takes care of it, right? Now, if you want to train a bigger model, which is with a model that is billions of parameters in size, then we have to shard the models across different GPUs, and in PyTorch you have to use something called as fully sharded data parallel. But JAX still uses the same device mesh, right? And if your model is in trillions, then you have to do all these tricks like tensor parallel, pipeline parallel, mixture of experts, model parallel, and all of these tricks that have to be implemented in PyTorch. But JAX still uses device mesh, right? So if you are training big models, then JAX is the way to go, because the distributed training setup is built into it, right? Whereas in PyTorch, it was added over the years, and we have to use all of these kind of tricks to make them train efficiently. Yeah, so like I said, PyTorch, they're constrained in types of the parallelism that we can use. We can only use shardings and tensor parallelism and pipeline parallelism and mixture of experts. But then if you want any kind of flexibility in how you want to shard the model and the data across all the different GPUs, then JAX gives a lot of flexibility over how we want to train big models. And one thing is that JAX handles all of this by default in the compiler, right? So you don't have to worry about how the data goes from one GPU to the other, like the inter-GPU communication and how it overlaps with computation, and it's all taken care of by the OpenXLA compiler. So when it comes to rapid prototyping and experimentation, PyTorch, I think it's a very good framework for rapid prototyping. So it's an imperative programming language. So whatever you type is what gets executed one after the other, right? Whereas that's not the case in JAX. So JAX focuses on functional programming like Haskell, and we want to, it focuses more on immutability and pure functions, and it's hard to debug, right, with JAX. So coming to community and developer support, most of the community is focusing on PyTorch. Most of the existing research that comes out from the academia and most of the results, most of the models that are being released are in PyTorch, and JAX is being pushed by Google. And right now, like NVIDIA and Microsoft, they all support both JAX and PyTorch. And JAX mostly focuses on TPUs, and they're like very efficient on TPUs, right, compared to PyTorch. So just to summarize, so this is the TLDR of like in what cases like JAX would work for you and in what cases like PyTorch would work. So if you're working with like big models and you want like non-standard distributed training techniques, then JAX is the way to go. And if you would prefer like functional programming language, obviously it has like lesser bugs and easier to maintain, so use JAX. And if your primary workload is running on Google TPUs, then JAX is the way to go. But if you prefer flexibility and rapid prototyping, then PyTorch. And if you prefer experimenting with the latest models that get released and the latest training frameworks that get released, then PyTorch is the way to go. So I think that's it from me, and I'll be open to questions.
One thing I was wondering, since JAX is so new or relatively new, how do you deploy the JAX models? Are you using Jetstream or any other framework to get them into production use cases?
Yeah, so JAX and TensorFlow are pretty interoperable. So the way we put JAX models into production is by converting them to a TensorFlow model. And TensorFlow can be deployed using TensorFlow Lite for edge devices or whatever the framework the TensorFlow ecosystem offers for putting it into production. So JAX is kind of like a transformation of TensorFlow, like a gradual transformation. So it kind of relies on the TensorFlow ecosystem for exporting the model.
Would love to chat offline how you do the conversion. That never really worked for me.
Oh yeah, sure.
Cool, awesome, thank you.
Well, thank you for this excellent analysis and breakdown here. I'm curious, since you're so close to this and you've got great insights on it, do you feel like these two models are these two approaches are gonna drive each other to close those pitfalls that you've exposed, or do you think there's gonna be a disruptor that comes along and offers the best of both worlds?
Yeah, sure. So I think both JAX and PyTorch started off with like their core philosophies, right? So JAX started off with the philosophy of being like the most efficient that there is to train, and PyTorch started off with the philosophy of being the most flexible, right, for programmer and developer friendly. But then both of them are converging together to support best of both worlds. So for example, Torch Compile is a way for PyTorch to support the features that JAX has, like compiling the model and like improving the efficiency and fusing ops. And JAX also has distributed debugging and JIT, which it tries to bring in that imperative nature of like PyTorch towards it. So it's kind of I would say that at certain point in time, like both of them would like converge to like one single approach, right? So, but then it's a matter of like when, I think. Yeah, because there is no one single approach that is the solution for everything. If you want efficiency, you have to give up like flexibility and the other way around. So yeah, we just need these frameworks to support both at the end of the day. So. Yeah.
Yeah, thank you. This was a great talk. In terms of like the packages and like one thing with PyTorch, I think it's 2 gigs, and the dependency, like what it depends on, is quite complex, and so version control is like quite painful. Is JAX better in that respect, or do they still have like similar issues with like the package dependency graph is?
That's a good question. So JAX still has a dependency hell, right? Just like PyTorch, and most of the complexities come from the fact that both of these rely on native extensions, like C++ extensions that are written, and they need to be packaged properly. So I think in that scenario, both PyTorch and JAX suffer from the same problem because both of them are just front ends to the underlying program. So I don't think JAX wins out in that case.
Thanks. For folks who have a web development background, but no AI development background, just take a minute or two and talk about setting up a development environment on a local machine, and then maybe just like, the old choosing an application, in the web development world, writing a blog is sort of okay, if you want to experiment and learn something, you would write a blog. What might that look like in an AI world on a sample project that you can develop locally to try and learn all these tools?
Yeah, that's a good question. I'm sure that there's like a lot of these tutorials that are there. From Andrew Ng. Andrew Ng has like a great hands-on tutorial on how to build this from ground up. Karpathy, Andre Karpathy has a good YouTube series where it's all like hands-on, right? And so yeah, I think there are a bunch of these tutorials that we can follow where we can train this from the ground up. So yeah, I think it depends on like which framework you wanna.
But that's what I was gonna say. And again, for folks who are noobs, PyTorch versus JAX, is there a preference there?
I think JAX is pretty new for tutorials. I think. So there are a bunch of tutorials for PyTorch. I'm not sure about JAX, but I think if you are comfortable with PyTorch, like JAX should be easy to like pick up.
Got it. Thank you.
Awesome. Thank you.